Lesson 5.1 covers simple interest. We're going to begin this lesson by looking at a few basic finance terms. The first one, principal, is the initial amount of money, and this amount of money can either be money that you're borrowing or money that you're investing. The interest is a fee paid for the temporary use of money. If you're borrowing money, you pay the bank or you pay the lender interest. If you're investing money, then the bank or the investment option that you're investing in pays you interest for the use of your money. The interest rate is used to calculate the fee that will be charged for the use of that money. So the interest rate is used to calculate the interest that's actually charged or credited, and it's usually a percent. Let's now look at the formula to compute simple interest. The simple interest formula is I equals P times R times T. In this formula, I is the interest charged. P is the principal, that's the amount of money that you start with. R is the interest rate. And T is time, and time is always calculated in years. In all the formulas we're going to use in this entire module, time will always be calculated in years. If you're given time in either days or months or weeks, you have to convert that to years. Let's look at the first example. You borrow $350 at 15% interest for 1 year. How much interest were you charged? And also, how much money will you actually have to pay back? So let's begin with the formula for the interest. I equals P times R times T. I always like to begin by listing what my variables are. So in my interest formula, I have an I, a P, an R, and a T. I is the interest, and that's what we're asked for, so that's what we do not know. P is the principal, that's the initial amount of money, and in this example, that's $350. R is your interest rate, that's 15%. We're always going to need to change this percent to a decimal. You change percents to a decimal by dividing by 100. If I divide 15 by 100, that gives me 0.15. And if you remember from grade school or middle school, even high school when you did these, to change a percent to a decimal, you move the decimal to the left 2 places. That's the same as dividing by 100. And finally, T is our time. This account was for 1 year, so our time is 1. Then we go to our formula, I equals P times R times T, and plug in the P, the R, and the T. So if I multiply 350 times 0.15 times 1, I get that my interest is 52.5. Now remember, this is money, so if you're given this as a final answer, use a dollar sign, and you do need the 0 after the last 5. So the interest charged was $52.50. Now if we want to find out how much money we will actually pay back, we're paying back the initial $350 that we borrowed plus the $52.50 in interest. If we add these, we get $402.50. So we're actually paying back $402.50. So note, the amount you pay back is the original amount, or the principal, plus the interest. So if I look at A, I'm just going to let A represent the final amount that I pay back. It's P, the principal, plus the interest. Well, if you remember, our interest was principal times rate times time, so let me plug that in. So I have A, the final amount, is the principal plus the principal times the rate times the time. Now, for simplicity, a lot of books give you the formula A equals P times 1 plus RT. What they've done, they've factored out the principal. If I factor out the principal from my first term, I'm left with a 1. If I factor out the principal from my second term, I'm left with an RT. So if I'm asked for the final amount, I could use this formula to compute it. So the formula for the final amount of a simple interest loan is A equals P times 1 plus R times T. And in this formula, A is the final amount. It's either the final amount that the bank pays us if we're investing money, or it's the final amount that we pay back if we're borrowing money. P is still the principal, that's the starting amount. R is still the interest rate, and T is still the time in years. So let's look at the next example. A person borrows $4,500 for 6 months at 9% interest. At the end of the 6 months, how much will the person have to pay back? So this time I'm not asked for the interest. If I wanted to, I could compute the interest and then add that to the $4,500. But since I'm just asked for the final amount the person will pay back, I'm going to use the second formula, A equals P times 1 plus RT. So I list my variables. I have an A, a P, an R, and a T. A is the final amount, and that's what I'm asked for, so I don't know the final amount. P is my principal, which was $4,500. R is the interest rate, which is 9%. If I divide this by 100, I get 0.09. And T is my time in years. Well, I was told at the end of 6 months. So since I'm given 6 months, I need to convert this to years. 6 months is 6 out of a possible 12 months. So I divide by 12 to get my years. Now, if you want to reduce that to 1/2, you can. But if you leave it 6 over 12, when we put this in our calculator, it'll give us the correct answer. So there's no need to spend your time reducing that unless you just want to. So I'm going to go to my formula, A equals P times 1 plus RT, and I'm going to plug in my P, my R, and my T. When I do this, I get A equals 4,500 times 1 plus 0.09 times 6 over 12. With each of these problems, I'm going to first show you how I enter these into the calculator, and then I'm going to come back to the PowerPoint screen and show you the steps. I suggest when I'm plugging it into the calculator, you just watch me. And then when I go back to the PowerPoint screen and I'm plugging in the steps, you can practice that on your calculator. Or you might want to pause the video and do the calculators yourself and then check your answers. With this problem, I'm going to follow order of operations. I need to do what's inside the parenthesis first. On the TI-36, I can type everything inside the parenthesis in one step. Your calculator will do the order of operations. Okay, I'm going to begin with what's inside the parenthesis. So I'm going to type in 1 plus, and then 0.09 times, and I'm going to enter the 6/12 as a fraction. So I'm going to do 6, hit my fraction button, and then 12. And I don't need the extra parentheses. And like I said, your calculator will do order of operations. So if I hit equals, your calculator has multiplied the 0.09 times 6/12 and then added the 1 to get 1.045. With this in your calculator, we're now going to multiply by the 4,500. So I'm going to say times 4,500. And this gives me 4,702.5. So as we showed on our calculator, we entered 1 plus 0.09 times 6/12, and that gave us 1.045. When we multiplied the 1.045 that was in our calculator by 4,500, this gave us 4,702.5. So that means the final amount we pay back is $4,702.50. When you're given the final answers, you don't have to use complete sentences like I am in the notes. I just want the final dollar amount. be sure to include the dollar sign. And if the number ends in a 0, like 50 cents or 60 cents or 10 cents, you do need 2 decimal places. Don't drop it off at 0.5. Include the 0.50. So let's look at the next example. A person borrowed $5,000 for 3 months. At the end of 3 months, he paid back the full amount of $5,500. What interest rate was charged? You can work this out 2 ways. You can either subtract the 2 amounts and get that the interest is $500 and then use your interest formula, or you can use the formula for the final amount. I've used the formula for the final amount, but if you work it the other way, that will be fine. So I'm going to use A equals P times 1 plus RT. So I list what my variables are. A is the final amount. This time I was given the final amount was $5,500. P is the principal. That's the initial amount of money. That was the borrowed $5,000. R is your interest rate, and this time that's what I'm looking for. T is your time, and it was 3 months. And remember, I always need time in years, so that's 3 months out of 12 possible months. So I divide by 12 to convert it to years. So if I plug this into my formula, A is the $5,500 equals P is 5,000 times 1 plus R times 3/12. Well, I'm just going to clean up the fraction part a little bit. I'm going to say 5,500 equals 5,000 times 1 plus 3/12 R. And there's several ways you could solve this problem. I'm going to begin by distributing the 5,000. Sometimes when I do this, my fraction goes away and it makes the problem a little easier to work. If I distribute the 5,000, I get 5,500 equals, well, the 5,000 times 1 gives me 5,000. And then 5,000 times 3/12 is 1,250. And you can do that on your calculator. You can say 5,000 times 3/12 to get the 1,250. Now to solve this equation for R, we first subtract 5,000 from each side. So we get 500 equals 1,250 R. Now if we divide each side by 1,250, we get that 0.4 equals R. Well, this is our interest rate, but it's the decimal form of it. And I always want to give the final interest rate as a percent. To change a decimal to a percent, we multiply by 100. So 0.4 times 100 gives me 40%. Multiplying by 100 is going to move the decimal to the right 2 places. So the interest rate charged was 40%. In the homework for this section, it begins with several problems where you're just changing percents to decimals and decimals to percents. I put those in there just for practice. I don't have any examples just containing those problem types in the notes, but we've done some problems like that in the notes. So when you're doing the homework, just remember to change a decimal to a percent, you multiply by 100 or move the decimal to the right 2 places. And the other problems, and these are the ones we do more often, to change a percent to a decimal, you divide by 100 or move the decimal to the left 2 places. Let's now look at another type of loan, and these are discounted loans. Discounted loans are loans in which the lender deducts the interest from the amount of the loan at the time the loan is made. The interest which is deducted is the discount. The amount the borrower actually receives are the proceeds. So with standard loans, with simple interest loans, you're given a certain amount of money, and then later you pay back a larger amount of money, and that larger amount of money is the original amount you borrowed plus the interest. With a discounted loan, the lender is going to deduct the interest rate. So say you get a loan amount for $10,000, the lender is going to compute the interest and subtract that from the $10,000 and give you the amount left over. But then when it comes time to repay the loan, you're going to pay a full $10,000 back. So let's look at the formula for a discounted loan. A discounted loan, R equals L times 1 minus RT. This time, R are the proceeds. That's the amount the borrower actually receives. L is the amount of the loan, and that's what you actually pay back. So you need to know the term proceeds, and you need to know what R and L represent in the formula. R, the proceeds, is the amount that the borrower actually receives. L is the loan amount, and that's what the borrower actually pays back. And like the previous formulas, R is the interest rate, and T is the time in years. So let's look at an example. You are approved for a discounted loan for $10,000 at 11% interest for 9 months. How much will the proceeds be? So again, you need to know what the word proceeds are. Proceeds is the amount of money that the borrower actually receives. If the loan amount is $10,000, then you're going to pay back $10,000. But the bank is not going to give you $10,000. They're taking out the interest up front. So if I look at my formula, R equals L times 1 minus RT. My variables are the capital R for the proceeds, L for the loan amount, lowercase r for the interest rate, and lowercase t for the time. So this time, the capital R, my proceeds, is what I'm being asked for. That's how much money the bank is actually going to give me. L is the loan amount, and that's the $10,000. That's how much I'm going to have to repay the bank. R is the interest rate, which is 11%. To change the percent to a decimal, you divide by 100, so I get 0.11. T is my time in years, but I'm given 9 months. So since I'm given months, I need to divide this by 12. So I get 9 over 12 years, 9/12 years. So let's plug these into our formula. I get R equals 10,000 times 1 minus 0.11 times 9/12. So I'm going to begin with what's inside the parenthesis. I'm going to say 1 minus 0.11 times the fraction 9 over 12. So let's look at that on the calculator. So your calculator can do order of operations. So we're going to begin with 1 minus, and I don't need the parentheses. I can type in 0.11 times, and I'm going to do the fraction 9 over 12. Now, you could have also said times 9 divided by 12, and that would work as well. And when I hit equals, I get 0.9175. I'm going to leave this in my calculator and multiply by the 10,000. So times 10,000 gives me 9,175. So this is the actual amount of money that I'm receiving from the bank. So when we entered this into our calculator, inside the parentheses we got the 0.9175. So on your calculator we typed 1 minus 0.11 times 9/12. Then we left that 0.9175 in our calculator and multiplied by 10,000, and that gave us 9,175. So the proceeds are $9,175. Let's look at the next example. You need $10,000 now, and you're offered a discounted loan for 2 years at 9% interest. In order to actually receive the $10,000 now, how much should you get the loan for? Since $10,000 is the amount of money I need the bank to hand me, $10,000 becomes my proceeds. So go to your formula, R equals L times 1 minus RT. And my variables are capital R, L, lowercase r, and T. Capital R are my proceeds. That's the amount of money the bank gives me at the time of the loan. So that's my $10,000 this time. L is the loan amount. That's the amount of money I'm going to pay back. And this time, that's what I'm asked for. R is your interest rate, which is 9%. If I divide that by 100, I get 0.09. And T is my time in years, and this time I was given years. There were 2 years. So if I plug these into my formula, I get 10,000 equals L times 1 minus 0.09 times 2. So just like before, I'm going to begin with what's inside my parenthesis. I want to simplify that first. So I'm going to begin with 1 minus 0.09 times 2. And that gives me the 0.82. Now if you look back at your paper, 10,000 equals L times this number. This time that 0.82 is not being multiplied by a number, it's being multiplied by my variable L. So I'm just going to rewrite it. You don't have to do this step, but it's 10,000 equals 0.82 L. So to solve for that L, I need to divide both sides by 0.82. So on your calculator, say 10,000 divided by 0.82, and this gives you 12,195.12. So that's the amount I need to make the loan for. So the amount of the loan should be $12,195.12. Let's just compare simple interest loans to discounted loans. Simple interest loans are probably the loans you're most familiar with, and discounted loans might be new to some of you. Well, both of these loans are based on simple interest, as opposed to compound interest that we're going to learn in the next lesson. And as I mentioned, most loans you're familiar with are the loans in which the bank gives you a certain amount of money, and you later repay that money as well as the interest. And a simple interest loan is a loan of this type. But there were some loans where the interest is deducted up front, and these are called discounted loans. Suppose you want to borrow $1,000, but the bank only offers a discounted loan. If you ask for $1,000, they're going to compute the interest and deduct that first. So suppose the interest came to $100, then this means instead of the bank giving you the $1,000, the bank is going to subtract that $100 and give you $900, and you're going to have to pay them back $1,000 at a later time. So if you ever have to get a discounted loan and you've got a certain dollar amount in mind that you need to borrow, the loan amount is always going to have to be more than the amount you actually borrow because they're deducting the interest up front.